Hey guys, welcome back to Mr. Chen class. Today we're going to go over our questions for mid-year exams, which is the calculates the elements in the at the equilibrium state by involving sig phase. Okay, let's read the question first as always. A 1.00 liters flask is initially filled with 2.00 moles of H2 and 2.00 moles of F2. Calculates the H2's concentrations at the equilibrium state. Okay, how can you calculate that? First and foremost, let's draw a rice table. What is a rice table stand for? Well, rice table R is stand for in our ratio. So ratio is going to be 1, 1, 2. So we're putting 1, 1, 2 in there. Initials, so I stand for initials. So what is initial in there? They have 2 moles of H2. Then we have to convert them into concentrations by using 2 times by using the mole, 2 mole to divide by 1. Then we calculate the concentration out. 2 divided by 1 is equal to, and have 2 moles in here. We also need to divide by 1, and also we get 2 out. Okay, so an HF never mentions which is ignored. Let me assume there's a 0 in there. Okay, and when C stand for change. Okay, then if this is 0, which means we're going to add 2x, because according to ratios, add 2x in here, and the one ratio, which means minus x. Okay, and E is a resource, or maybe equilibriums. So equilibriums, so there's add 2, and also the 2 minus x, and also this going to be 2 minus x. Okay, so this is actually the first step we're going to do. The second step is going to be the KEQ. Okay, so KEQ, what 2 formula you have seen of in by calculating KEQ. So the first one is going to be KEQ is equals the concentrations of products is equals the concentrations and divided by the concentrations of reactants. That's the first formula you have to be familiar of. So, and the second formula, KEQ, is going to be the Ka values of reactants and the Ka value of product. So this is a quick review about which one is conjugate base, which one is conjugate acids. So this one is H2CO3 and I think SO3 2-, and we have to deduce which one is going to be the acids and which one is going to be the base. Now, first thing we have to notice, this must be the base because D cannot donate anything. So you have to be absorbing one. So it's SO3 minus, because absorbing one, like subtracting one, and this one is going to be the acids, and things because they take out one, so become HCO3 minus, and this one is going to be the the base, and this one is going to be the acids. Okay, so this one is acids, this one is acids. So in KEQ, this kind of questions, if they want to, if using the Ka value, we have to find the Ka value of this acids. We have to find the find the Ka value of this acids and find the Ka value of this acids using this acids to divide by the, because this is a reactant, and divide by the products, which means this is going to be, we have to find the Ka values of H2CO3 and also find the Ka value of SO3 minus reactant divided by product. Okay, but however, in this type of question, we're not going to use this formula. Using this formula is good. Okay, let's see how we're going to do. Well, using KEQs, which is product divided by reactants, and the concentrations, we put down the formula first. Must be put down formula first because this 2 is going to become a square, and H and also the F2. Okay, now can put down the numbers in there. Slightly upwards, then you can see that. Okay, so 2x and putting 2x in the at the tops, and also 2 minus x, because this times together which becomes a square, and divide by the square root on both sides. Not divide, like square root on both sides, which mean this 1.00 times 10 to the square, this become 10. Okay, if this become 10, and what we're going to do, 10 times this number. If 10 is going to times this number out, be careful sig face this time, because this have 3 sig face. We will square root them, is also keeps in 3 sig face. 3 sig face times 3 sig face, and also we have to keep into 3 sig face. If 20 it came into 3 sig face, which mean is 20.0. If this is 10.0, which is 3 sig face, and remember there's one in the invisible one in the fronts, which keep in 1 sig face, but we never round them up. Remember, we add 10.0 x and on both sides, which is become 12.0 x, and this is become 20.0, and keeping 3 sig face. And this one, these two add together, we have to be careful this the decimal here, because adding and subtraction is decimal. So 10.0 times add 2, and because this only have 1 sig face, and this we have to put in underline and 1 in there. We're going to divide by 12 on both sides, which is get us so it's 20 divided by 12, which is get us 5/3, and we never round them up. 5/3 is equal 1.666, and we never round them up until we finish them. So we because this is 3 sig face, this is 1 sig face, so answer have to be 1 sig face. But the answer is that we never finish that, because they want to find the H2's concentrations. How we're going to do that at equilibrium state? Sorry. So we're using 2 to minus our numbers to subtract our number 5/3. Then we get 1/3. So 1/3 is actually 0.3333, something like that. And if that's because that's 2.00 is actually 3 sig face, so but as in here it's 1.66 is going to 1 sig face, so the answer is going to be 0 if we're going to care about sig face. But however, the real answer is just 0.333. Thank you for watching. This is the end of the video. Hope you like this video. Thank you. Hope that helped.